All right, welcome back, Algebra 2. We're looking at day 2 of 5.4. And day 2 is going to be very similar to day 1. We're going to be factoring. Our learning target is I can solve higher degree polynomials using factoring. So we learned in, section 4.4 or 4.5 that we can not only factor different quadratics. Let's just say we have, something like this. X squared plus 5x plus 4. There's a quadratic. We learn we can factor this, but we also learned from the factoring we can solve this whole equation as well. So what we mean by that is we could use the zero product property and say, all right, well, I can factor this to x plus 4 and 1. But that also means since it equals 0, I could then set each of these equal to 0 and get my two answers to solve this equation using what we talk about as a zero product property. So that's kind of what we're getting into today. A lot of it is review, which is a good thing because this factoring is a large part of algebra, and we're just taking another day at it. So warm up, go ahead and pause it and try to see if you can factor these 3 problems. Okay, so I'll go over them pretty quickly. But number 1, you can take out a greatest common factor. You can see you could take out a 3 from this trinomial as well as an x. So I'm going to take out a 3x and then rewrite this trinomial by dividing out the 3x. So we're going to get x to the 4th minus 6x squared plus 5 there. Now we could think about, how can I factor that green part? Because I already took out the 3x, and this is a 3-term polynomial. So we can think about, can we break this up into 2 parentheses? And the answer is going to be coming from, if we try snowflake here, this is one strategy that we've been using all along. Notice that our first term here is an x cubed, or x to the 4th. But the actual coefficient here is 1. So I'm going to put 1 here. Then a times c is 5. The middle term, or b, is negative 6. And this does factor, and it works out. If I do negative 5 and negative 1 here, that's going to multiply to positive 5, yet add to 6. So this right here will be 1x minus 5. But instead of x, it'll be x squared. So we're going to say this is a 1, or just x squared minus 5. And then the second one is going to be an x squared minus 1 there. And if we need to double check that, you could multiply that green part out if you're in doubt and just see, does that actually work? And it does. It multiplies out. Now once we did that once, we could say, can we go any further? Well, I can tell you from experience that this cannot be factored, but this one right here that I'm putting in like pink can be factored because that's the difference of 2 squares. So without going into detail there, this would stay as x squared minus 5, but this part would become x plus 1 and x minus 1, and this would be the complete factoring of number 1. Number 2, looking at it, first thing we always do in factoring is thinking about a common factor. So I'm looking at this whole thing and saying you definitely can divide out a 2 from this. So I'm going to take this, I'm going to take out a 2 and rewrite the problem, because we can do that. X cubed minus 8x squared, or 8x. Actually not 8x, it's 4x squared. Plus 5x minus 20 if we take out a 2 from everything. Now when we look at this, since we have 4 terms here, we want to think about factor by grouping as a possibility. So I'm going to try to group this into basically 2 groups. By default, I'm just going to kind of keep these first groups together. So I'm going to kind of do this. And then just make another group, 5x minus 20. And then factor by grouping is really just taking those 4 terms, thinking about them in really just groups of 2, and seeing if there is a greatest common factor that I can extract out from each one of those, in the hopes that once we look back at that, we have a like term that we can then combine those with. So let's keep going here. I have a 2 here, and then when I look at this, what can I factor out of that? You can see I can factor out an x squared. So I'm going to take an x squared out of that first grouping to get x minus 4. And then I'm going to look at this second grouping, and you can take out a 5 from that. You can pull out a 5, and then that would become x minus 4 as well. And so that's exactly what we need to happen for factoring by grouping to work, is that when we do that process, you can see these x minus 4s, these common elements, do show up. So that gives us a way to now write the problem like this. So we're going to have 2, but now we're going to take this red part, right? And I have an x squared and I have a plus 5. So that's going to become one of my parentheses. And my other parentheses will be the like term here, the x minus 4. So x minus 4. That is it for this factoring. X squared plus 5, you will not be able to factor. Again, that's from experience. If you think about x squared plus 5, just off to the side here, if you think about it, there's really no middle term there. And so you could try snowflake or anything here, but there's nothing that multiplies up to 5 but would add up to 0. And so it's a clear indicator you can't factor that part. So this is it. All right, number 3, you look at this, and again, first step always when we're trying to factor something is taking out the common factor, and you can see that they both have b's here, specifically a b squared, and then also we could take out definitely a 3 here, actually a 6, so we can take as much as a 6b squared from that polynomial. So I'm going to take out a 6b squared from that. What's left over is going to become 5b minus 9. So, and we look at these factors that we have left over, and that's as far as we can go. So that's it for number 3.